So in this particular question, rather than being given a model of how X explains Y, like in the previous exercise, you're actually given raw data. And in the raw data you see are the number of people working, including the mean and the standard deviation at a company, the number of salespeople on a floor, like a sports authority, as many people, or at a bookstore, like it says here, at Barnes and Noble. And then the Y variable is the amount in sales closed by these people working the floor of the store in thousands of dollars with a given mean and deviation. And the first question is, what is the slope? So if you were working this by hand, you would need to multiply the correlation coefficient, which is a measure of how X and Y relate to one another variation-wise. And then you would multiply this, you would use this correlation factor as an adjustment to the rise over the run of the model. So in this case, the rise and the run of the model are given by how much variation there are in sales with respect to how many variations there are in the number of salespeople working. How Y varies relative to how X varies. So to do that, I would have to calculate the correlation coefficient of the model somehow. I'm given the standard deviation of Y and the standard deviation of X in people and in thousands of dollars. So 4.7 is $4,700 per salesperson, per 5.4 salespeople. So I would multiply 4.7 times R and divide it by 5.4. Now, how do I calculate the correlation coefficient? That is a function of how well correlated the number of salespeople and sales are in the data. And you do that on StatCrunch. So I'm going to open the data in StatCrunch. Wait till there's a pop-up window connecting this activity to StatCrunch. Now I'm going to share that window with you. And to calculate the correlation coefficient between two quantitative variables, I go to Stats Summary, Stats Correlation, and select both variables and compute. In this case, the correlation coefficient is 0.9736, meaning that the correlation between these two factors, between these two variables, salespeople and sales revenue, is very positive, strong, and linear. So there's a very strong connection between the sales revenue at the store and the number of salespeople at the store. So I'm going to take that number and take it back to my model here and paste it there and do the math. Multiply the rise in variation over the run in variation by the correlation coefficient. And I'm going to get 0.85 or 0.847. That's one way to get the answer to what is the slope, and then I would have to do the math, do the algebra for the y-intercept as well. To avoid needing to go back and forth between the problem and the calculations necessary in this problem, the best thing I recommend doing is actually not just calculating the correlation between the two variables by using this command that I just demonstrated, stats summary, stats correlation. It's best to go stats regression, simple linear, stat regression simple linear, select the x factor and the y factor and run the computation of the regression, the whole regression model. The whole regression model will look like a line that has a slope and an intercept. So as you can see, the slope I calculated is 0.848 and the y-intercept is 9.164. So this number here, 0.848, is very much what we calculated by hand and included here. In addition, what does this slope mean? It means that there's an additional sales of $848 for every additional salesperson at the store. Why $848? Because that's 0.848, which is the sales in thousands per unit salesperson. So I need to multiply the 0.848 by 1,000 to get it into dollars. And then for the intercept, I simply go back to StatLab and I notice that what the intercept is, 9.164, and I'm going to copy and paste it into my assigned work here, which tells me that this company does $9,164 in sales when no salespeople are at the store. And that doesn't make much sense, because how can you make sales without salespeople? And the answer is it could be online sales. So the amount in sales is going to be the intercept and the slope. That's just the equation that we built. And now if we want to know what sales we predict with 18 people working, we would multiply 18 times this slope plus this intercept, and then multiply everything by 1,000 because the model is in thousands of dollars. So you could do the math by hand. Like so. Or you could go back to StatCrunch, and in the process of options edit, in the process of running this regression, you could scroll down the list to where it says prediction of Y when X is 18. So by putting in 18 salesperson, we can then see in the regression output that would be $24,430. If you want to round it to $431, that's fine as well, because there were 70 cents left over in the other calculation. So this is how you would use the stat regression simple linear command that I demonstrate in the videos for chapter 4 on this computation. If sales were actually $23,000, then this number is $1,431 bigger than the prediction is bigger than the actual. So the prediction is an exaggeration, and we have overestimated what should occur. So I hope that this is useful in your computational work on this problem.